Hi, my name is Dorian Karakus. This is my screencast video for my project one, explaining how I built, how I created the system calls in the kernel. So first, I started with creating a global variable in my kernel printk.c file. And this global variable was called log rep. You can see right here, an expert symbol to make it global. And this just helped me keep track of the log number that I was on, and I'd be using it later in all my other functions. And then from there, I had to set the system call number within the arg entry syscalls file. And so in here, I set the system call number and the number I would continue to use later throughout when I was using the syscall function, which is right here, the three, the set proc log level, get proc log level, and the proc log message. I just followed the same format as the system calls above. And I was able to put that there, and this was used later in my functions inside of my user space for when I called syscall. And then I would I would declare the function prototype. And this was within the syscalls.h file in the include Linux files. Oh, 1 second. There we go. And so this was all the way at the bottom. And so all I had to do is write the ASM linkage prefix, and then I would write the rest of the line for the function with the sys underscore in front of it, and then include the parameters as well as just declaring it in this syscalls.h file. And where I actually created my system kernel or system call files in the kernel, the actual functions, was within the kernel sys.c file. And so within this system.c file, put up here, there we go. At the bottom of the file, I was able to put in all my functions, starting with the set proc log level, using the log rep global variable that I'd used earlier, and this root UID to create a check for a super user. So this is my super user check. It returns -1 if the user is not a super user, and is able to get their ID from that ID file, UID variable, and they get the current code and send it to the uid.val variable. And this is how I check for the level being in between the range of 0 to 7. If it's not, it would just return a fail. That's the end of that function. It would just return 0 at the end. And this system will define 0. This is because this takes 0 parameters that get proc log level, and all it is just returning the log level of the system. And so this takes 2 parameters, a proc log message, and it essentially just prints out the current level and level message if it's not the correct level to be printed in the D message. And it will also have multiple checks for length and if the string copy, if the string fails from the user, as well as printing out the message as well into the D message. And so within my process log directory, I have all the proc log message files, a proc log message, set and get proc log message. Those are my make files that I use to compile and create the libprocesslog.a library. And then outside of the process log directory, I have the send log, set level, and get level C files, as well as their compiled versions, as well as the harness tests and library tests to test my functions against the expected outputs that they had included in the test files and the test CPP files.